Okay. Good evening, everyone. Welcome to the 8th edition of Colombo Big Data Meetup. Unfortunately, we are seeing little low in attendance, mainly due to the prevailing weather conditions. Some reason every time when we organize this meetup, something has happened. Last time it was a huge protest in Colombo. This time it's distance, so we have to analyze the relative relevance between our meetup and the other events. Right. So before we start up the meeting today, last month we did the workshop at Uavella University. Participation was more than 100 students, and it was well participated. There are a lot of questions, and we were able to give some kind of a basic idea about the big data and other peripheral technologies. So we are planning to do another workshop in coming month. Dates are not yet planned in Eastern University. We'll let you know the dates as and when we have done with the planning. Hopefully you can, if you can participate, that's great. If you can't participate, still you have friends over close to that area. I think it's in Oliville, right? Yeah, yes, it's in Oliville. So if you have friends close to that area, you can ask them to join this workshop. So okay, let's come to today's event. So today we have two sessions lined up. First session, real-time analytics. First session is on real-time analytics, stream processing, and beyond, done by Mahesh Madhushankar, Associate Technical Lead at Cake Labs. Mahesh is a graduate from University of Moratuwa at Faculty of Engineering, and he has 5 years of experience in data-related technologies. He is an associate member of IESL, that is Institute of Engineers Sri Lanka, and is currently leading a data team at Cake Labs as an associate technical lead. So I'll welcome you for the session.
Thank you. Hi all, good evening. I'm Mahesh from Cake Lab. I think he already introduced myself. So let's move into the presentation. Today's topic, real-time analytics. What you can expect from this session. First, I will start with the basic, the real-time analytics, the basic concepts and stream processing technologies. They are more theoretical concepts. Then I'll try to move into Apache Storm, the main topic, and ATTL framework and some best practices. They are our own experience within last 2-3 years. We are playing with Apache Storm and these stream processing technologies. So within this session, I'm planning to share some of our own experience and best practices, limitations, and challenges. At the end, I'll try to give some alternatives for stream processing technologies. If you want to get real-time reporting, real-time analytics, what are the alternatives for stream processing? Without doing stream processing, how can we get something like that? You can define it in multiple methods. In simple, we can say identifying meaningful patterns in data, we can define it as analytics. If you have a set of data, how can we do analytics? You can execute set of queries, you can extract set of data, and you can perform it by yourself. Or else, if you are going in more advanced manner, you can implement the ETL, you can do the extraction, transformation, and you can load it into a data warehouse. It's there. If you are going with latest microservice architecture, let's say with the microservice architecture, you may have multiple systems, multiple source databases. In such system, you can sync those data into a central repository called data lake. We can implement this with Hadoop, or maybe EMR, and there you can do the deep dive. You can analyze data from data lake to data warehouse. If you want, you can extract some set portion of data and store it for the further analysis. This is one approach. There can be multiple architectures for this thing, but there is one major limitation with these approaches because they are batch oriented. We are processing something 1 week old, 1 day old, for 1 month. We don't know what's happening right now on my business. Most of the companies, from their business point of view, the most important thing is identifying what's happening right now on my business. Can't we analyze that? Yes, it's real-time analytics. Before moving to real-time analytics, if we want to get real-time analytics, the best method is doing stream processing. What's the data stream? We can define a stream as a sequence of tuples. Then, again, another question, what's a tuple? Tuple you can simply define as a list of elements which can contain integers, strings in a very basic definition. So, sequence of such tuple you can define as stream. Processing of such stream we can define as stream processing. Simply, we are processing data when it is being produced. When you click on a button, we get it as a stream and we process that. We may generate analytics on that. What are the available stream processing technologies? The first one, our main topic, Apache Storm. Then IBM Stream, a well-known product in the market. Then Tobacco Streambase and S4. This is Yahoo product, still in incubator level. Am I missing something? A famous technology? Can someone raise your hand if you know? If you think am I missing something here? Stream processing. What do you think? Spark. They call it as Spark Stream. Is it a stream processing technology? What do you think? If you know the answer, just raise your hand. Let's give it for you. It can be right or wrong. Just give answer. Oh. Okay, I'll give the answer for that. Actually, it's not a stream processing technology, although they call it as stream processing. Why is that? This something other than my presentation, but I would like to highlight this thing. In Spark streaming, they will receive data as a stream, but from there they will divide it into smaller batches. So when that batch size goes to 0, it's look like stream processing, but internally it's batch processing. Although that batch size is smaller, it's not stream processing, it's batch processing. This from the Spark site itself is saying it's batch processing, not stream processing. I'll go back to my presentation. Batch was real time. The first two, Storm and S4, they are mainly for stream processing. Then Hadoop, the famous big data technology. When we are discussing about big data, it's Hadoop. So Hadoop and Spark, they are mainly for batch processing. Based on your business requirement, you can go with either stream processing or batch processing. But if you are going with stream processing, you will get something in real time. I'll directly move into my main topic. This is Apache Storm. Before going to practical implementation and rest of the things, we need to know basic concept on Apache Storm. The first concept is spout. We can define a spout as the source stream source for our topology, stream for our system. So it can be maybe a Kafka data stream, maybe a Hadoop file system, maybe a CSV. We can get data from there and we can pass it to our processing elements. Then the next concept, vaults. Processing elements in a topology. The first one, we are performing transformation operation. We are converting the letter T into red color. So in the second one, we are doing we are getting two streams and we are combining them and generating one stream there. Like that, we can do whatever the operation we want: filtering, aggregation, joining, and transformation. Then what is the topology? If we can combine set of spout and bolt together, then we can define it as a stream topology. So from spout it will generate stream, then from the bolt it will do the processing and it will convert it into a meaningful pattern, maybe analytics. The next concept, stream grouping. Based on the incoming stream, we can divide it into, maybe in the first one, from spout to bolt A and bolt C, coming stream into two groups, maybe based on field value or something. But from bolt A to bolt B, we are randomly distributing it from bolt A to bolt B. Like that, within the topology, we can group our incoming stream into multiple methods. So in stream grouping, there are set of concepts. Mainly we are using first one, shuffle grouping. That means randomly distributing incoming stream of tuples from first one to second one. It's something like this: bolt A to bolt B. Bolt A to bolt B, we are randomly distributing. The second one, field grouping. The stream is partitioned by the field specified in the group. That means something like spout to bolt A and bolt C, we are dividing it based on a condition. Next one, reliability. With Apache Storm, this is something most important. Storm, it guarantees at least once delivery. Once we submit a tuple there, it guarantees at least once delivery. How it can achieve this? Starting from the spout, once we pass our tuple there, it will go to the next bolt, from there to the next one, like in the number sequence. When it reaches the last bolt, that means it has completed processing there. Then from that bolt to previous one, it will send acknowledgement. From that bolt, it will send again acknowledgement to reach the first spout. From there, it will mark as success. Otherwise, that spout, it will resend the same tuple because it will notice it as a failure. So it will resend the same tuple and it will emit it again to process. So with this setup, it can guarantee at least once delivery with Apache Storm. So you can 100% guarantee once you submit a tuple, it will process within the topology. Okay, now I am going to practical implementation and rest of the things. Previous ones, they are mainly theoretical concepts and rest of things. Those are background study. So, can we implement a ETL flow using Apache Storm? Yes, we should be able to do that. This is a traditional batch-oriented ETL flow. We implemented it using Talent ETL. The first component, it is HDFS input. It can read Hadoop files and maybe a CSV and pass that data input into the next processing element. The next processing element is the filtering. That means based on the data set, we are performing a filtering operation. The third one is the DB lookup. We are performing some DB lookup against the incoming data stream. One is the aggregation operation. And finally, we are loading that data set into a MySQL table. This is a sample ETL job, batch-oriented one. Can we implement something similar to this with Apache Storm? Yes, if you can design a HDFS spout, something similar to HDFS input component in Talent, and if you can implement filtering, MySQL lookup, and rest of the things with Apache Storm and Bolt, you can get something similar to this. So there is a challenge from the ETL developer point of view. As a ETL developer, mainly we are doing just dragging components and doing the configuration changes and connecting it. It will do the job. But here, when you are going with Apache Storm, you have to write it by yourself. You have to implement these codings. You have to implement HDFS spout, filter bolts, and rest of the things. It's coding, and maybe it may be little hard to an ETL developer. That's one challenge with this. Okay, I'll take another example. This is my ETL flow. The first one, as an individual component, let's assume it can process 100 tuples per second. But the second one may be filtering. It can be a complex logic, so it can go up to maximum 10 tuples per second. The third one is 50. The fourth one 40. The last one is 30. What will be the overall performance of this topology? Can someone answer? 10. Yeah, that's correct. Overall performance depends on the slowest step of that sequence. Can't we increase this performance? If we want to get 30 tuples per second, can't we achieve that one? With Apache Storm, we can do that with horizontal scalability. Simply, if you notice a performance issue, you can increase the parallelism of that board, and you can have 3 parallel boards there. So with that, you can get it up to 30, because now we have 3 parallel boards. Although HDFS is out, it can process 100. The next one, it will be a bottleneck, so it can process up to 30. Then from the rest of the things, they can do the same. So all together, it will be 30. If you want to get 50, but number of aggregate balls to 2, and we can increase the number of MySQL output to 2. So with 2 aggregate balls, we will get altogether 80, and this one it altogether 60. So initially, with the initial setup, we had 4 boards and 1 spout, altogether 5. With this setup, now we have 3 filter boards and 3 other boards, altogether 6 board and 1 spout. That's 7. If we are increasing it up to 50, we will have 2 additional aggregate and MySQL output boards. That means altogether 9. Like that, when we are horizontally scaling this up, we will have maximum higher number of spouts and board combination. Then I'll move it to cake ETL framework. We developed this based on Apache Storm to make ETL developers' life easier, and we are using this in our production. We have implemented predefined set of spouts and boards. The first one, HDFS, CSV, Kafka, and rest of the things. And for basic DB operations, basic ETL operations, we have implemented set of boards, loader boards, filter boards, splitter boards, and rest of the things. Let's say if you want to implement an ETL flow, as an ETL developer, you can just implement a configuration XML file with the type HDFS spout, parallelism 1, and rest of the information. Similar to this, you can implement rest of the board configuration in XML files, and we can integrate it as a sequence. Then once we submit this to the cake ETL framework, it will generate a Storm job for yourself. That means once we complete the configuration and once we do that XML file level integration, it will generate the relevant Storm job, and we can run that one. So it will make ETL developers' life easier. So they don't need to worry about the implementation in terms about Storm and rest of the things. Simply they can do this configuration, something similar to traditional ETL development, and submit it there. Okay, now we have ETL. Now we have completed the ETL development. Then how can we deploy it? This was our initial POC when we are starting with Apache Storm. So I'll take that as the example scenario. Initially, we set up 4 node server. They are on AWS EC2 instance, 4 EC2 instance. On top of that, we deploy Apache Storm. First, I will explain the internal structure of Apache Storm. Starting from Nimbus. The main coordinator of Apache Storm is Nimbus. Then we will have a set of distributed coordinators. They are zookeepers, something familiar to us. Then for each node, that means here we have 4 nodes. For each node, we will assign 1 Storm supervisor. So altogether we will have 4 Storm supervisors there. Then for each supervisor, we can assign 1 or more worker process. Simply when we are assigning it, we will assign it equal to the number of available CPU cores there. Let's say if we are deploying it on a 8-core machine, we can assign 8 workers there. That's a standard but not a rule. So the best practice is when we are deploying it on an 8-core machine, assigning 8 workers there. If it's 4-core, just assign 4 workers there. Then executors. They are something similar to threads. And the last one, tasks. I will explain workers, executors, and tasks in my next slide further. This is one such example, a worker process. You can assume it as a CPU core. On that CPU core, we can see in gray color boxes, the larger one, you can see 3 gray color boxes. They are executors. They act like threads. Internally, the yellow color ones, they are 2 tasks which running on 2 different executors. But the other one, third executor, we are having 2 tasks. That says, in an executor, we can have 1 or more tasks. If I am going back to my previous slide, in a single executor, we can have 1 or more tasks. In a single worker process, we can have 1 or more executors. In a single worker process, we can have 1 or more executors. Then in a single supervisor, we can have 1 or more workers. Okay, I'll take a ETL example. This is a storm topology. The first one, blue color one, that's the spout. The next one is the green color, it's a bolt. And the third one, yellow color one, again bolt. The first one, you can see parallelism as 2. That means we are having 2 parallel spouts there. The next one, green color, again parallelism 2. We are having 2 parallel bolts there. Parallelism hint is 6. That means altogether we are having 6 bolts there. 2 plus 2 plus 6, altogether 10. That means it will require 10 executors. We are deploying this on 2 worker processes. So from Storm itself, it will equally distribute. So in the first one, you can see in a larger box, you can see 5 boxes there. And the second one, you can see 5 boxes there. They are executors. Then in green color one, we have defined 2 tasks per that executor. That's why we are seeing 2 components within the same box, the green color one. But in a executor level, we are having 5 on first worker process and we are having 5 on second worker process. This is with this deployment. What that means? If we resubmit the same topology, in the next time, we cannot guarantee we will get the same deployment structure like this. We may have 4 yellow color ones on the first one, and we may have the rest of the things in the other worker process. So from Storm itself, it will do that. So it will balance the load, but we cannot predict the way it's distributing the executors and tasks. Okay. There's a concept called topology length. Normally we are defining it from starting spout. When we emit the tuple, the number of steps it needs to pass from the first one to the last one, we define as topology length. Here, although we have 7 processing elements there, from a tuple point of view, the first one, then it needs to go to either filter board, then MySQL, aggregate, and the last one. So altogether, it's 5 steps. Fine, the topology length as 5. This was our initial POC. We set up 2 8-core machines as our Storm cluster. Then we deploy it there. Server 1, we can see the green color, that's spout on server 1, the first worker process. Then filter, we had 3 filter boards there, 2 on server 1 and the other one on server 2. Then MySQL lookup component, it's on server 2. The aggregate, it's also on server 2. MySQL output, it's on server 1. This randomly distributed by Apache Storm, so we cannot predict the distribution way. If we resubmit the same, we may get different setup, but we will get equal number of executors on both machines. The empty boxes, they are available workers but there's nothing to process on those workers. Then we emit one tuple to this topology and try to understand how it's processed. First one, it goes in this path, starting from the spout, then this filter ball, and MySQL lookup, aggregate, and it completes the processing. But when we submit another tuple there, it goes in complete different path, but it guarantees the processing. With this setup, this was our initial POC, we were able to achieve 160 tuples per second. It's a considerable higher number. So we are good. We try to implement our actual production implementation with this. Then we had to face a lot of challenges and issues. We had to learn something by ourselves with researchers and best practices. So I'll share those stats. First scenario, this was our production requirement. Implementing a topology with topology length equal to 30. That means one spout and 30 transformation components, 30 bolts. Altogether, we are having this is a lengthy topology starting from spout to 30 bolts. That's mainly based on the business requirement. If I want to perform filtering, aggregation, transformation, and rest of the things, we may get considerable number of transformation elements there. So initially we implement that one with the total spout and bolt count equal to 30. The meaning of that is we set parallelism to 1. We don't have parallel components there. So spout is parallelism 1. All the bolts we set it to parallelism 1. Number of executors should be equal to 30 because we don't have parallelism there. Then we use the same server setup and we deploy it there. So from Storm itself, now we don't have 3 worker slots there. 15 to plus 1 and 15 to second one. So for each worker, now it has assigned 2 executors. But only for last 2, it's only 1 executor because altogether we are having 30 bolts. So when we distribute it equally, it's 15 per 1 machine. So only for last 2, it's 1. For the rest of the thing, it's 2. With this setup, we were able to achieve 40 tuples per second. We assume this may be due to the length of the topology because initially it was a 5 transformation step. With that, we were able to achieve 160 tuples per second. Now we are having 30, it's 600% something higher than that. So getting 40, that's fine. But when it comes to the business requirement, they expect us to get it up to 100 tuples per second. How can we achieve this? Yeah, simply, as you think, we did the same. We increased the parallelism. In some, starting from the spout, we increase its parallelism. Maybe in some cases, we increase up to 10. In some other cases, 7, 8, maybe various numbers with that calculation. So finally, it ended up with 172 spouts and bolts. Then we deploy it there on the same cluster 2-node setup. Now 11 executors per each worker. That means for each CPU core, now we are assigning 11 threads. Altogether, we are having 176 threads there. What do you think? From the performance point, when we increase the parallelism and when we deploy it from this one, can you guess? Okay, it reduced. Our initial base value, it was around something 40. Now it's lesser than that. The issue is the CPU utilization and memory utilization. We have overload this setup. So we are assigning 11 executors per worker, and we are having more than 80 executors in server. So that's a considerable higher number. So what then? What's the option? Horizontally scaling the server faster. Two additional nodes. They are 8-core machines. So now we can guarantee we are not assigning more than 6 executors per worker. So with that, we can guarantee we are having lesser number of CPU utilization on each server. Then we check the performance again. It increased, but not the expected level. Our initial objective, it was around 100. So base value is 40. It increased, but not the expected level. Then we check the issue. If you submit a tuple, something similar to my previous example, then we check the execution path. It's something look like this, a mess. Starting from first execute a thread on the first server, then it goes to the third one, then fourth, again coming back to second. So within the topology, it need to pass 30 transformation steps. To achieve that 30 transformation steps, it's going more than 25 times within this server setup. Maybe from first server to second one, second server to back again the first one, like that. So with this, there was a network delay. That's why we couldn't achieve that required performance level. In Apache Storm, it's internally using NetI as the network communication layer. Maybe I think it's with 0.8 and 0.9. Now they have changed it, but still there's a limitation. We cannot just add in servers. We cannot increase the performance. Maybe there's a cutoff value. From that point onwards, you cannot increase the performance due to network delay. That's the basic rule. So we had the same issue. The network calls, the higher number of network calls, it shows the minor performance improvement. Okay, then we go with another setup. That's increasing the server size. Previously we had 8 core machines, now we increase it up to, so we get 2 16-core machines there, and test the same. We emit a tuple there, and we try to understand what's that. It's this. What was the issue? Now we are having lesser number of inter-server communications, but we are having higher number of inter-thread communications. In Apache Storm, it's using LMAX as the inter-thread communication library. So there's a issue on that. Actually, it's not an issue. Having multiple threads on the same machine, there can be a limitation, because just horizontally scaling a server, we cannot increase the performance. In summary, the first scenario, that's our base. Without parallelism, we were able to achieve 40. Then, with the same server setup, we increase the parallelism. It reduces the performance. Then, the third one, we add 2 additional servers. Assuming in the second one, we are having lesser, we notice high CPU utilizations and memory utilization there. So that's why we add 2 additional servers. Communication delays and rest of the things, it shows some performance improvement, but not the expected level. The last one is worst. Can't we achieve 100 tuples per second? This is our solution. We tried with server combinations and rest of the things. The recommended setup, if you are going with more than 30 transformation steps in the single topology, this is related to the topology length. So when you are implementing a ETL flow, if it's less than 8 or 10, this can be changed, because this is related to your business case. But when you are deploying that ETL topology, Storm topology on a server cluster, you need to consider these things, especially the network connectivity delays and the inter-thread communication delays, and you need to find the best performing ratio for that. So we set up initially 8 CPU core, 4 machines, altogether 32 CPU cores. That means we can assign 32 workers there. The best matching ratio is 8 workers per topology, and maximum 8 executors per worker, then maximum 2 tasks per executor. This is, I am again highlighting that this is related to this specific scenario, that 30 length, that topology with 30 transformation steps. So based on that, based on your, find out that one. So altogether with this setup, we can go up to 160 spouts and bolts. So I checked my previous topology. We had a major issue there. because the overall parallelism we increase up to 172. So we had to reduce it up to something less than 160. So we get it to 156. Then the total number of tasks 156. Then we divide it by 2. The executors 78 and workers 78 divided by 10, 8. Yeah, we can deploy it on 4-node cluster. With this setup, we were able to achieve 100 tuples per second. How? Okay. Actually, when we are deploying it, it's not just look like this, not the first workers on each server. Maybe server 1, maybe 2 and 5 in server 2, maybe worker number 1 and 6, something like that. But for the easy visualization, I highlight only the first section. 2 workers on each server, and we deploy our ETL on that setup. From Apache Storm, it assigns the available number executors for each worker, and within these 4 servers, we were able to deploy the 156 executors. With this, we can reduce the number of inter-thread communication. I think that's clear because now we are having lesser number of workers in one server, and also, but we are having same server setup, 4 nodes. How can we reduce inter-server communication? If I am going back to my previous slide, in this setup, we allocate all 32 to the same topology. With that, we are giving higher chance of getting executors on different servers. But when we reduce it, the number of workers to 8, now we are having lesser chance of getting it deployed on multiple servers because now we are assigning only 2 workers from each server. So with that, it reduces the number of network calls and number of inter-thread communications. This is actual production stat. The initial requirement was to load 40 million records within 5 days. Altogether, 1 billion plus transformations, because per each topology we had more than 25 transformation steps. So we had to perform more than 1 billion transformations, and we had to process 40 million records within 5 days. That was our production requirement. So we had to process 7 to 8 million per day. With this server setup, with this topology, we were able to achieve 92.59 tuples per second, something like that, with 25 transformation steps. Not only that, within the same cluster, we were able to deploy multiple ETL topologies. You can see the first one, that's blue color one, the initial one. With parallel to that, we were able to deploy multiple topologies there. So, the individual topology can go up to 100 or more than that tuples per second. So altogether, we were able to achieve a considerable higher number of processing with the lesser CPU and memory utilization requirement. Let's say here we altogether it's 32 cores and 15 GB RAM per each machine, altogether 16 GB RAM and 32 core cluster setup. With that, we were able to deploy multiple ETL flows and achieve the same rate. So in summary, if you, based on your requirement, when you are deploying the topology, try to find the best mapping ratio. Otherwise, you may just deploy it on a 4-node or 8-node cluster, and it will utilize the entire cluster, but it won't give the expected performance. If you identify the best performing ratio, you may be able to deploy multiple topologies there and get the best performing ratio. That's something you need to find with related to your solution. Then I'll move into limitations and challenges. First thing, the cost. If you are going with stream processing, there's a significant cost. That's the reality. So if you are going with 4 EC2 C3 2x large servers with the hardware, the internal storage and rest of the things, normal AWS cost will be around something $2,000 per month. This depends on the organization. Maybe If you are doing more than 50% of reports on real time with real time history, maybe a 1 or 2 user case, in that case you need to consider this. Please keep in mind, when you are designing a stream processing technology, there is an underlying cost with the servers and infrastructure. The second thing, Nimbus and supervisor failure. As I explained, the Nimbus is the main distributor coordinator, and supervisors are, we are assigning it for each server. Normally, it should recover with Nimbus and supervisor failures, but with our experience in the last 2-3 years on Apache Storm, there were few scenarios it couldn't recover automatically. And sometimes we had to manually interact. Mainly, there were few bugs on Apache Storm as well, especially on supervisor failures. When there's a running topology on the server, and if supervisor fails, it cannot automatically restart. In such cases, we had to manually interact with those scenarios. But more up to let's say up to 60-70%, it's automatically recovering and doing the rest of the things. But in executor, task, and worker level, up to now, we haven't noticed any manual interactions. We don't need to do any manual interaction there. It will automatically handle executor level, worker level, and task level issues and the failures. It will automatically redeploy the cluster. It will automatically deploy the topology and rest of the things. In some cases, for Nimbus and supervisor failures, we have to interact with it. The third one, the acknowledgement. As I mentioned in my previous slide, with Apache Storm, it guarantees at least once delivery. So when you emit the tuple, it will keep in memory the status of that tuple. When it reaches the last port, it will send that acknowledgement message, and that's the only way it's marking it as in success state. But when you are having a topology with 30 transformation steps, can you imagine the issue? So it needs to keep in memory all the 30 steps and the status of that tuple. When you are emitting more than 7 to 8 million for that topology, you have to keep in memory all the acknowledgement messages. We had the issue with this acknowledgement system. So in our scenario, we had to disable this Apache Storm. It's an inbuilt acknowledgement system. So we implement it by ourselves, separate acknowledgement system to guarantee at least once delivery. We disable it due to memory utilization issue. Those are some issues. Maybe in your scenario you don't get that one, but keep in mind, if you are going with the lengthy topologies, there can be a memory issue. The last one, 100% CPU and memory utilization. What does it mean? Let's say when we deploy Apache Storm or something, we are going with Ambari or CloudTrail, some setup, and with that we are deploying it there. In that case, initially we try to use the same servers for Hadoop data storage as well. We have the storage for Hadoop data system and Storm for the process CPU and rest of the resources for processing. But when we deploy Storm on a cluster, due to high CPU and memory utilization, the other Hadoop data nodes and name nodes, they would fail. So we had to keep it in a separate cluster, the Hadoop cluster in a separate one, and Storm in a separate cluster due to that. So mainly, if you are deploying Storm, you cannot use the same servers for some other tasks. It's utilizing high memory and CPU. Okay, there were few limitations and cost and the rest of the things. If you think I cannot go with this because it requires this much of cost and the rest of the things, but still I need some real-time reporting, real-time analytics kind of thing. What are the alternatives? One such alternative is column-oriented distro. If you keep your data in a column-oriented database, you may be able to get some real-time reports, not with the transformation and rest of the things, but just some some analytical reports in real time you may be able to get with column-oriented distro. Especially with the latest version of MS SQL, I think it's come with the column-oriented indexes. In simple, what's the column-oriented distro? Normally, we store data in normally we store data in a sequential of files in a raw structure. But in a column-oriented distro, you will keep separate data file for each column. Let's say if you want to take the total sales summary of this table without accessing all the DB files, we can directly get that file and perform the aggregation operations here. It's something like that. Don't worry, I'm not going to explain this because this can be a separate session. Maybe in future we can discuss about the column oriented and rest of the thing. It's just up to you. You can search on these things. With that, I'll complete my session. Just gave a high-level introduction and best practices and rest of the things. If you have any question, you can ask. Anything?
Yes. You said that real-time.
Yeah.
When you say real-time media, does that mean that we have the resources with the delay change?
Yeah.
At that time itself, data is available for analytics. So
Yeah.
There's a data.
The delay is 1 to 2 minutes maximum delay because with our setup we have multiple source systems, and from there it's getting synced to the central data lake, and from there we are getting the data stream, and we are doing the stream processing with the Apache store, and we are loading it to our analytical data warehouse and the recording purposes. So altogether, the total delay is 1 to 2 minutes. Yeah.
That's the first question. Question number 2 is for the what about the predictive analytics? So predictive analytics, this is some predictive analytics. We need to build additional algorithms for the dynamic data. This kind of dynamic data.
Yeah.
So what are the approaches that we can going with this kind of the topology? What are the approaches we can take for predictive analytics?
Yeah, I think that's especially with your implementation, because in a board it's like a pre-template. You can implement whatever the coding you want. If you want to implement algorithm there, you can implement it on the board itself, and you can configure it as a board. With related to our use case, we implement set of such boards, maybe with some small algorithms, not a complex one. We implement some small algorithms to identify some patterns, maybe some clustering kind of thing, especially for k-mean clustering kind of thing. We implement some boards there, and it perform that clustering, and it will pass it to the next level.
So now let's say clustering, you made the clusters.
Yeah.
But with the new data coming in, that clusters can change. Right?
No, within the same tuple, the incoming set, we are grouped it into multiple small groups. Let's say within one tuple,
Okay.
you can get 10 or 20 records.
Okay.
Data elements there.
Yeah.
Within a board, we are grouping that incoming tuple, the incoming set of that tuple, into multiple groups.
So my question is, that's fine.
Yeah.
So let's say new data is coming in.
Yeah.
There will be 2 minutes delay.
Yeah.
With the new data, existing clusters might be changed altogether, right?
Yeah, existing cluster, that's fine.
Yeah.
So with that, there's already saved data.
Yeah.
We are not doing anything with that one.
Okay.
We are mainly focusing on the incoming stream and doing the calculation there.
I have a couple of
Yeah, sure.
Mahesh, now when we compare this with platforms like SQL Server and Oracle,
Yeah.
we know that column-oriented indexing is there and real-time analytics is there. So if I have to decide if I have to go ahead with Hadoop and store, or do the same thing with Oracle or SQL Server, what are the factors I use for determining it?
Yeah, especially that will depend on the number. Let's say number of transformation steps and rest of the things. Especially if you have a considerable number of transformation steps to perform, and if you want the number of the frequency of incoming stream. Let's say within 1 or 2 hours, if you are getting a considerable higher number of stream, in that case, I think it's better to go with this one rather than.
Is there a threshold for deciding?
Actually, that's depend on the business case. I think.
Let's take about simple one. Let's say we get about such set of CSV file.
Yeah, I
completely unstructured. Let's
Yeah.
say it's structured one, but only thing is the volume, and you're continuously getting data, and not much steps. Let's say we have to just split a couple of things and get the data out, and then convert it to some sort of visualization. But in that case, can I go ahead and get something like SQL Server? Or still, I need this.
I think in that case, it's better. Can I get the number of volume, data volume? Something?
Let's say 5 GB or 10 GB per hour.
5. Okay. In that case, I think it's better. I'm not sure on the SQL Server performance values,
Okay.
but with Apache Store, I think we can guarantee that you can go with that one to get the expected performance. Maybe with this ratio, but I'm not sure on the MS SQL Server because I don't have much experience on that one.
the discussion, we have a benchmark, right?
No.
Yes, like how do we
No,
decide it?
in Apache Storm, still no one has done such benchmarking. With this study, we did something similar to that with our cases.
I have implemented certain, not up to that level, but a considerable amount of records with SQL Server. So it worked fine, but I haven't tested with 10 GB, 15 GB size data. So that's why I want to know about threshold.
There's no such standard benchmark or something in the market.
Okay. My other question is, let's say we process this with either Storm or Spark. Okay. Now, can I get the output immediately through the Storm or Spark and put it to a visualization without putting back to another container? Can I read it immediately once the processing is done? Can I read it immediately and push it to a visualization?
Yeah.
Is that the way, or we have to load it somewhere else and use that container for visualization?
Currently, in our case, we are storing it in a data warehouse, and we are
That's
getting
going
it.
To be relational.
Yeah, that's relational data warehouse, and we are getting it from there. But if you want, you can store it in a, let's say, Elasticsearch or maybe a DynamoDB memory database or something. You can just push it there, and you can get it from there as well.
When you say push it again, are we going to use a physical container for storing data? My question is this: like, let's say I'm creating a report,
Okay,
that has a visualization.
Yeah.
So I'm continuously getting data, and I can pass this data set to Storm or Spark.
Yeah.
And the processing is getting done through that.
Yeah. Then
Can
you need
this component directly connect with Storm or Spark and get the output?
No, in Storm or Spark, it's doing the processing itself.
Okay.
So then after the processing, we need to keep it somewhere, maybe in some caching layer or maybe a permanent storage or something.
The report cannot be connected directly to that output.
Yeah, that output.
That's a standard way of implementing it.
Yeah, in most of the cases in Spark or Storm, we are processing it and loading it to a caching layer or maybe a data warehouse.
So which means we are not storing the whole thing, just the output, and then pass it to the visualization.
Yeah.
Right?
Just to add to a question, when we are selecting solution, maybe for Storm and for the solution,
Okay.
we might need to consider the possibility also. Most of the solution we have described are open source solution which have been available. We all know how expensive all the solutions are. So just want to highlight that we need to consider that possibility.
Yes, that is
yeah.
one of the things we need to consider, but most of the time when it comes to large enterprise level organization, they don't care about the cost, but they really want is whether, what's a component we can use it, I mean, for implementing, plus we have to think about the support, maintenance, upgrade, there are so many other things to be considered, right?
Yeah, especially with in Oracle, that support and everything is outstanding. Especially with open source solution, support and maintenance a little bit hard, but that can be facilitated.
Okay.
If we are good with that.
Right.
So that's my personal opinion.
Actually, thanks, Ajay. This is our DB administration.
Okay.
Okay. Anything else? In that case, I can. Thank you all. Let's keep it.
Right. So let's before that let me welcome the people who joined in between the session. Let's go for the second session. It should be done by software engineer, data science and analytics at Tech One Global Private Limited. Harita is an IT graduate from Rajarata University of Sri Lanka, a deep enthusiast in machine learning and data science, especially in applying machine learning and deep learning paradigms in developing intelligent applications. He's interned at Microsoft and currently stationed at Tech One Global as a software engineer for data science and analytics. He's serving as a Microsoft student partner, and he contributes to the tech community with sharing his experience through his, which is shared in the meetup.com as well. And his session is on okay, let the machine read behalf of you, a glimpse of into it, the text analysis and machine learning. So let me welcome Harita for the session. So to you, Harita.
Good evening, guys. I think you all are okay with the sound without mic, right? The people at the back. And if I walk here, it's okay, right? Because I'm not at the stage first. Right. Good evening again. You're not sleeping, right? Okay. Let's go into do a session. Previous session was about stream analytics and how to deal with the data streams. That means the data comes rapidly. So here, what we're going to do is we're going to do a session, discuss a bit about some kind of a boring data. Because we all know text is so much boring. But many of the insights and many of the useful things that deal inside the data is like hidden inside these textual data. So analyzing these textual data and getting some useful information is very important in the business. But you know, like reading, we don't like reading right now because as the millennials, we have smartphones, we have all the devices, and we are not fond of reading. So let the machines read on behalf of us. So I'm Harita Tilakaratna. I'm working at Tech One Global in data science and analytics. So that's me. Right, text. So what is the last book that you have read? What is the last book? Any thoughts? Sorry? Single novel. Okay, that's good. I do read single novels, not studio Prasanna, right? Okay, right. So you know, like previously, before people used to communicate through symbols. Then letters got its birth. After that, the numbers got its birth. So many information right now people tend to use text. Though we all are computer people, IT geeks and all, we deal a lot of time with maths, right? So we are very comfortable with the numbers. But others, like the people who do arts, or people who good with linguistics, or the people who good with archaeology, they are very good with words. So they tend to write those things, write their facts and all inside text. And also, when you go for some website, when there's some feedback or something like that, we normally like we are very lazy of writing feedbacks, but the people normally write feedbacks in textual format. So people thought of analyzing the text that coming in this World Wide Web. Then they try to use some statistical methods and some linguistic techniques, but those techniques were not accurate. And they moved for the thing called machine learning. So the machine learning is becoming a hot topic right now, right today. It's not a new thing. It's not a newborn thing. It's like 30, 40 years maybe. All. So, like previously text was very much interested and many people use text for their things. And then I want to answer for this. Here we have like how many? 15, 16. Right. I want to count. So who's in support research or working in IT? That means doing some research or working in IT field. Right, majority. And then who's doing research, only research, or doing some BA, means like business analysis, or end user. End user means someone who's using IT applications. Not an IT guy, like doing BA from some stat firm or something like that. Consultancy firms. Right, we have to. Then, who's working for a solution provider? Doing a startup, making some solutions like document management, ERPs and all. Anyone? We have. Okay. Right. Any other guys? In any other field? Archaeologists? Right, no one. So in all these fields, we have to analyze text. In the first field, if you're working in IT or doing some IT research, obviously you have to deal with the text coming from the user. And the second one, as a researcher or a business analyst, you have to deal with text a lot. And then, as a solution provider, think you are having a ERP, or think you are having some kind of a HR management system. One guy is going to leave the office early, and he's writing a letter. Think you have like 3,000 plus employees right now here as like virtue staff. So what you're going to do? You're going to like HR manager going to read all those emails and reply for those things, to analyze whether he can give a leave or not. So those are some scenarios. And like at my company, we are having a solution called Anadoc, a document management solution. There we are getting like a company in Philippines, they are scanning like 4,000 documents per day. That is like 17 lakhs of documents right now we have on our system. It's like 234 GB or something, the database. There's SQL. So those are huge amount of text data that we have. So you need something to analyze these things. Previously in business intelligence, you know about business intelligence, numbers. We deal with like how's the cost, how's the profit that we get. All those things were in numbers. But when like numbers are not enough, we had to go for text. So we'll talk on some applications that we can use this text mining.
Normally, people use two terms. One is text analysis and one is text mining. We can't say like this is the boundary of text mining and this is the boundary of text analysis. Normally, text mining is mostly used by the academia. They use the term text mining. But in the industry, mostly the term they use is text analytics. So in business, can you suggest some application that you can think of that businesses using? Have you seen anything? Have you seen any like business applications? Have you gone to any cinnamon restaurant, cinnamon hotels also? In cinnamon hotels, you will get a tab to give the feedback. Normally, Facebook also they give it, right? So they give a tab to give the feedback. In the tab, they have a column like your comments and all, right? And also, any Twitter users here? Twitter, right? Anyone who followed last night Google I/O? Right. Anyone who followed the last week build? MS Build? So normally there are some applications. What they do is they get the hashtags. Think I'm not sure whether what is the hashtag. What was the hashtag for Google I/O? Hashtag Google I/O something like. So what they do is they fetch all the tweets. Tweets means the text. The tweets and analyze those tweets and say this product is doing good or bad within the community. That means some kind of a sentiment analysis. Those are some business applications that we can do. And the product feedbacks, how the community is thinking about the product. We can do those kind of things in business aspect. And in academics, obviously, you know, in academics we have a lot of text. So you can use those texts for classification as well as for some kind of some research field. So those are some aspects. Social media, as I explained earlier, Twitter and also in Facebook, they do text analytics available. Software, any software application that you know doing text analytics, using text analytics. So what they do is like previously I explained about the product that we build. We are using text analytics to make tags. That means think we have a document with 24 pages. Previously I told like we are scanning like 4,000 documents per day in a single campaign. So end of the day, like end of the month, you want to search that 24-page document. You only know the name. Can a person like remember all the names of PDFs or something? Because our naming conventions are like super crazy. We name as final or final. Those are the names that we normally use. So what we do here is we tag those documents beside of the text that they have inside those documents. The pictures. Anyone using iPhone here? Right. In the iPhone, the photos are tagged. Right. The photos are tagged according to the faces that you see in the photos. Or if you search like someone having a glass of wine, if you have a photo of glass of wine in your iPhone photo app, that will pop up. Same as that, we are tagging the documents using the content that have in this document. And security. Everyone knows about ransomware and all, and everyone knows about spams and hams, right? Famous example for text analytics. So, what the inbox does is it deviates the spams from the hams using text analytics. I'll show an example in my demo. And the chatbots, a hot topic. Anyone have used a chatbot? Right. Anyone who built a chatbot? So chatbots becoming a hot topic. So chatbots using a text analytics. Previously, what they did was they just did some like text matching and procedural instructions, those things. But now they have moved forward with language understanding, some frameworks like Louis. Those things are coming up. We'll discuss on those things later. And what do people do with documents? Like documents. How many documents, like the paper documents you have right now with you? How many paper documents like you keep in safe? Birth certificate, and I don't have a marriage certificate, and then not the like nothing else. Degree, no, not yet. So we'll say for the average person 5-10 documents, right? For a company, how many hard documents? Like okay, for a company like National Archives, how many? And we are doing a project for land reclamation in Sri Lanka. So the major aspect that we have to consider on that is their documents are super huge, like this, because they are not in the A4 size; they are like super huge. We have to bought even a robotic scanner to scan those things. So those are the documents that normally we have right now. We have to put those things into an electronic manner. We have to publish those documents and share it with the colleagues and manage those things. Index and search, we have done those things with search engines and normal SQL queries. We have done those things. And categorizing and classifying. How to categorize these documents? Think of a company that a normal average person, but just passed out with O levels, is doing the scanning process. He is scanning all the documents coming to him. Just scan. He doesn't know whether it's a national ID or maybe a birth certificate. How to classify those things and move those things into separate folders. Then we can use text analysis. I'll show how. Then info extraction. This is very good for us because what we do is we don't go for the lectures at the final line. What we do is we get all the things and just put all the views like this and just keep. So we just extract the information, only the important ones. Text analytics for that also. This one, I'm not sure whether you can see this thing. This is a data visualization done by Beautiful W. You can search in there. Beautiful W. What they have done is they have represented all the mathematics, science, and technology articles in Wikipedia. Using text analytics, they have done this. Some kind of fancy text representation, data visualization. And anyone know this diagram? Anyone? Yeah. This is a famous one. This is one of the famous. This one? There was a film. Yes. Sorry? Imitation Game. Yes, Imitation Game is the film of the England companies. Yes. This is the Turing test. Anyone knows what is Turing test? Turing test is a test that Alan Turing not invented. He proposed this one. He said outside two rooms. He can't see these two rooms. In one room you can see a normal human, and in the other room you can see a machine, a computer. So the task that this guy is having is to say in which room is the machine is. If this guy can't tell exactly where this machine is by asking some questions and getting the answers. Alan Turing said that AI has what? Normally, like AI is becoming a hot topic. So text analytics is like the primitive stage of natural language processing and gave birth for natural language processing after that. So we can't think of text analytics without this NLP. So we'll move on to these fields. I'm pretty sure you can't see these things. I'm sharing the slides so you can just read these things. These are the major tasks that you can find in text analytics. One is the syntax operations, and the next thing is semantics. Here I'm only discussing few, others you can refer, because other than that, this would be a boring lecture, right? You know about lemmatization, right? We have lemmatizing is like this. I think we have example here. We'll go with that, and we'll explain with that. And then here the post means parts of speech, and others will discuss later. This is for reference. And we discuss a lot of text analytics. So what we going to do with the text? How should be the text analytics process? You know about machine learning, right? What we're going to do is we're going to do some machine learning with the text. Previously, you might have done machine learning using numbers, right? Anything you have done with machine learning? Any task that you have done with machine learning? No one that question? No one have that? That? Okay. What you have done? Okay. Anyone heard of iris data set machine learning? That classifying three orchids, Iris, Centrosa, Virginia. So in those things, what we have had was numbers. But here in text analytics, what we have, those texts can be come as CSVs. Pretty good. Then we have CSVs. But sometimes those things might be in other data sources, might be in JPEGs even. Even the scan documents comes in PNGs or JPEGs. So what we have to do is, we have to do the preliminary formatting first. That means these things should be out of like distortions, if there's like some kind of dots or those things inside the text, you have to remove those things. If you're doing OCR, you have to do those things first. And the next thing would be tokenization. We'll discuss about tokenization first. After that, stop word removal, and then we'll go for analytics. We'll come to this slide after. And when we normally talk about text analytics, this is the first word that normally people use, bag of words. Anyone heard of bag of words? Anyone have any idea about bag of words? Right, in bag of words, what we do is, we have a document like this. We have some words here. And what we have to do is, we have to build a model called bag of words. This is a representation of this text document. We have to make this bag of words. What we do is, we get all the words in here. That means, let's say this is having 100 words, not the duplicates, only the unique words, and we list them like that. Like we have well, said John like that. So that is the document that we have here. Well, said John. Here said James. There. This is the text that we have. These two sentences are the document that we have. And what we do is we get all the unique words that we have. We have well, we have said John, there, and James, and we put the frequency of each word in that. So this is the basic bag of words concept. Anyone can so I would say this bag of words is a representation of this document. I would say like that. This bag of words is a representation of this document. So there's a huge disadvantage. Anyone can say the disadvantage? What is the huge disadvantage that we have? I would say you can represent this document using this one. Exactly. The order. You can't say in which order these words are in this document. You can't say the order. That is the major disadvantage in bag of words. But right now also, many text analysis tools use bag of words as their major text representation technique. Right? And the next one is vector space model. I'm not going to discuss this because that would be a bit boring. But I have put all the things in my comments, so you can read those things in your slide set. So this is using another method called vector space model. This is much better than bag of words, I would say. So this is used in modern text analytics tools. And the most important thing, TF-IDF. Anyone heard of this term, TF-IDF? That means a term frequency, inverse document frequency. TF-IDF, anyone heard of this term? If you are not familiar with these, just write down, and simple Google searches will help a lot. TF-IDF. So, we talked about representing these words, and what we're going to do is we have huge set of documents like these. Think we're going to do a classification, right? You know, right. Think we're going to do a classification. So I said in the vector space model, the number of words that you have in the document, that means the number of words that you have in the bag of words, going to be the number of dimensions that you have in this vector space. This document is having 1000. That means it's having 1000 dimensions in the vector. And this is having 10,000. That can be happen because this might be a book. And think this is having 5,000. With that, how many features that you get, how many input features that you get for your machine learning model? 1,000, 5,000 is 6,000, 16,000 features. Can you, in a machine learning, in deep learning, it would be okay, I would say. But in a normal machine learning model, in a computer that we have, in a server that we have, go for 16,000 features, input features. That is not possible. So what you have to do is you have to identify what are the most important words in those documents, so that we use this term called TF-IDF for this task. This is a simple calculation. What we do is TF means term frequency. That means term X within document Y. Right? We have a document called Y. Think we have a term called X 3 times. What we do is frequency of X in document Y. What is the frequency here then? 3. And then we have a log here. So total number of documents, how many documents we have? Let's say 4. We have 4 documents. Then what we have identified is in how many documents that is there. We'll say in here also we have X. We'll say in here also we have X. In how many documents? 3. So this is the simple equation that you can get the TF-ID. So if you good with math, you will get a flash. If there's a rare word in the document, if there's a rare word like some bombastic rare word, that will get a higher TF-ID. If there's a common word like and the, for, those things, will get lower TF-ID. So before going for these TF-IDF, what we do is we'll remove those stop words from the text that we have. Class of stop words. In English, there are many stop words, and we call them as stop words because they are not giving so much weight for the documents that we have or the textual content that we have. But remember, normally normally researchers have proven you have to use, like, you can get this kind of stop word list even by searching the net. But remember, if you're going for an industrial application, building something particular industry, use a stop word list that is specifically built for that particular industry. Think you are doing some kind of a medical applications. In the medical field, sometimes the words like, we'll say, like, I'm not sure, we'll say the word of might be a useful word, right? In some applications, in some domains, some words that we omit as stop words are very much important. Removing all these stop words from your textual content, think of the domain that you're going to remove the content, right? And then like if you want to do some machine learning thing, you need to have a data set. Testing, those things, right? I need to explain that also. Training testing, right? Right. So training these kind of natural language processing and textual analysis, the training data sets that normally we have is called as corpus. Singular form of that is called as corpora. So this would be the text, like training tests that you're going to use in natural language or textual processing. So they are large and structured set of text. Normally they are like dictionaries, online dictionaries, or like normally in XML form. What they do is they have each word and some kind of description about whether that word is adjective or those kind of things. So this is the process that I explained previously. Can you see this thing at the back? We have the text first, and we do the basic filtering, removing all these punctuation marks and all, and then we'll do tokenization, separating this word into this sentence into words, right? You might think like separating this sentence into words can be done using like simple C# or Java program because we have spaces between words, right? But this is not working in the languages like Chinese or Japanese because they have words using only a single character. So you can't do that space separation thing in those languages, right? And then we group these multi-words. You can say like ping pong is two tokens, but in here multi-words grouping, what we have done was ping pong is a single word. After that, we have removed all the stop words and we have the result here. So this would be the feature set we're going to use in our machine learning model, right? We then parsing, one of the tasks that we're going to use. Parsing is like we have parse trees. Normally, if you search tree banks like NLP tree banks, you will get many parse tree libraries. So this is like naming each part of the sentence. That means naming each word of the sentence with particular meaning. Is this a verb or a noun? So those are the things that we do with parsing. Here's the word segmentation. As I showed you before, this is a Chinese example. So this is the separate representation of a door. Two words, but you have three characters. I don't know, 3 or 4. Right? Two table lamps. We have 3 words here, but we have like 4 characters here. Use that space trick here. Post tagging. Anyone heard of post tagging? Part of speech tagging. Part of speech tagging is tagging these words according to their grammatical meaning. So I have a document, so I'll show you this post tagging in my demo. This is an interesting case. At the demo, what we're going to do is we're going to build something like this, NER, name identity recognition. So this is the technology we use at the document management. Here we have a text, a long text. Can you see the highlighted? Highlighted. We have Einstein here. We have United States here. Adolf Hitler here, and Berlin Academy of Science is here. Institute for Advanced Study in Princeton is here. So what are these words? What are these words? You know about proper nouns, right? In English, in singular that is some. Proper nouns. Visheshana is adjectives. Proper nouns, sarva nouns. Right? Those are the proper nouns. That means Einstein is the name of a person. Institute for Advanced Study is an organization, and United States is a place. So, for this whole set of words, that means whole set of documents, you can use these words as a summary or a set of tags. Think a person wants to search a document that relates to Adolf Hitler. Right? Normally what we do is we do a full text search using SQL, but like storing all these data in a SQL index or column is. But what we can do is we can just store these names and entities as tags in the pictures. Normally, you are the hashtag generation, so you know the hashtags. As hashtags, you can use these words as the hashtag for this document as it is. So that is pretty easy to search the domain. And sentiment, we discussed about sentiment analysis, right? Any explanation need? Right. And aspect mind, the next thing. After going for the sentiment, the next thing would be think like analyzing some text and say the user is good with the price. That means think this is a feedback, some kind of product review. If the user is good with price, but the user is not good with the build quality, and the user is like pretty satisfied with the support that he got with the product. So we have to analyze these kind of things. What we can use is this technology, name entity recognition plus sentiment. We can use those things both in a single application. Move to the, we'll get the theories apart and we'll move to the most interesting one, demos. Anyone familiar with these logos? Anyone use these tools? OpenNLP, this is an Apache license, and NLTK on Python, right? And this one, Nudge, I haven't used, but I searched in the net. That is one of the, they say like there is one of good application that we can use, Nudge. And this one, Stanford NLP, this is pretty much good in universities, Stanford NLP. So these are some dev tools and libraries that you can use for textual analysis as well as for NLP. Right. Text classification. These are some machine learning algorithms that you can use for text classification. I'll show you a demo in the demo. Naive files, you know, those things, SVM, k-nearest neighbor, and neural networks. Obviously, neural networks comes in all places. Right. The first demo, I'll do this one. Right. So in the first demo, what we're going to do is, you know BBC, right? You can search for this demo. If you search BBC News Classifier in the net, this will come up. This is in the Kota Intelligence Gallery. I uploaded this thing. So what this one does is, anyone heard of BBC News dataset? BBC News datasets consist of 2,000 plus documents. That means news articles that in 5 different categories. The categories are business, entertainment, politics, sport, and tech. Right? All these articles are jumbled. Right? All these articles are jumbled, and they have a label with it. What we're going to do is a supervised learning, not unsupervised. What we're going to do is we're going to train a model, a machine learning model. Say if we have another news, and we're going to put that news into a machine learning model, and the model will say this is whether it is a business news, whether it is an entertainment news or a politics news or what else. We're going to do here. This is some kind of an advanced classification, a multi-class classification. Same scenario used in spam and ham. Right? So what we're going to do is we're going to do this thing using cloud-based machine learning. With some explanation. Anyone need some explanation? Right. HTML, it's like this. Previously, for building machine learning and those things, we had to code a lot, and we had to go from the scratch and build all those things. But many of the people here are software engineers, right? Anyone from different field, not software engineers? We have some. Okay, in which field, sir? Okay, database administration. So previously, to do this kind of tasks, we had to have people who is good with machine learning, that means good with those kind of theories as well as in programming. But with the modern aspects that we have, what we can do is we can build all those machine learning models using drag and drop technologies, drag and drop things, and integrate those things into our applications. Because all of the clients that we find in the market are searching for intelligent applications. They need some kind of some tricky things in the application. Software engineers might not be able to do those things. So this is the best tool that they can use. All can see this, right? Right. If you're going to like test this thing, just search BBC News Classifier HTML in Google, and you will get this thing. What you can do is you can just click this button, open in Studio, and that will come up to your browser. That means your HTML account, and you can test this thing. This is public. You can download free, right? And yeah. People at the back, can you see the things? Can you guys like move quickly to the front seats? Come. I'm not going to ask any questions. Come. Because you can't see the things. We have like 2 seats here, 2 front seats. Come. Be quick. Right. Here I have uploaded all those news articles. I will show you the CSV file. So this is the CSV file I have. I have the numbers down here, and the news article here, and the label of that. Whether it's a business news, right? Whether it's a business news or something like that. We have 3 columns and 2,000 plus rows. So we have the categories like business, sports, politics, technology, and entertainment, right? And the next thing what we're going to do is we're going to select columns. What you just want to do here is just drag and drop. If you're not familiar with HTML, go home and check this thing. Just drag and drop. We had a session previously. Samudraya from 99X did that thing. So you just type this thing here, select columns, just drag this thing up and put this, right? That is simple as that. I'm going to select the news and the category columns, and I'm getting that output from here. And the next thing I'm going to do is edit metadata. That is like renaming the columns that I have. Be cleaning missing data. I told you before, you have to clear the outliers or clear the missing data that you have on that textual data, same as numerical data. So you can do this thing, clean missing data. What I have done is a simple thing, because BBC news data set was not with outliers or something like that. It was pretty clean. Just I did was like, if there's a column without a label, I just removed that whole. Sorry, if there's a row without a category, I just removed that category. That row. Then I have a small R script here. Anyone familiar with R? Anyone familiar with R? R language? So R is pretty good with ML as well as with NLP. What I have done was like I have commented all the things, so you can just read. I have told. So what kind of words that you need to get? Only the words that have a minimum length of 3 characters and maximum length of 25 characters. I assume that there's no words more than 25 characters. There might be, but I'm not getting those things. And then in the text pre-processing, I removed the punctuation marks and all. There's a separate function in R to remove those things. And then I calculated that TF IDF here, document frequency, and those things here. And then I sent that output for the output tool. Steps like text pre-processing is also here. You can find just like this. So here I'm getting like, as I remember, if I just click this thing, that will go for like 10 minutes to load this thing. I tried that thing, so I'm not going to show that thing. So here what I done was, there was like 60,000 features of this data set. And then using Chayescard algorithm in ML, what I had done was using that TF-IDF and those document frequencies, I just selected the top 5,000 features from that, top 5,000. And then the algo I have used was a multi-class neural network. That means because this is a multi-class classification, I used multi-class neural networks. And tune model hyperparameters, this is a thing that you can use to, like there are many parameters in neural networks, right? The hidden number of hidden nodes, number of hidden layers, and the learning rate. Those are some parameters that we can change. So bias value, you can change those things. So I have used this one to explain neurals here. Tune models, that means swapping those parameters and see what is the best suiting model. And we'll see how's the score coming in. Till this is going to run. I'll show you this one. In Azure ML, there's a separate tab called Text Analytics. Can you see this thing? Here, you can just build something like this and make your clients like wow, right? Just a simple application. SCs, software engineers. Have you heard of application? Building intelligent applications. Because previously what we did was like just many applications were just add, update, delete, right? Get some data and show some data and those things. But now what the people need is something more than that, something that we can do more than that. So here, software engineers are pretty good with calling for APIs. Good with APIs, right? Calling some API, putting a JSON in, and getting a JSON back. You know those things, right? Anyone not familiar with that thing? Calling an API? Right. Here, you can use the power of machine learning using an API. In Azure ML, what you can do is you can build an API and host that thing on Azure and just call that thing using put an input using a JSON and get back your result. Here, I have a text. This is a text I have that is about some Google thing. Google is bringing the Android operating system some kind of a news. So I have just drag and drop these items. I'll show you. Detect languages, and this one is extract key phrases from text. key phrases. This one is pre-processed text. What you can do is you can remove stop words, lemmatize, and detect sentences of that. Normalize the case, that means making the uppercase characters to lowercase characters. Remove numbers and remove special characters like punctuation marks and all. Remove duplicate characters if you have. And this one, named entity recognition. I explained this thing previously, right? So I have a text here. Like how many characters here? Many characters, right? I was going to do is I ran this thing previously because it's getting time. If I click the output here, what you can do, what you can see is what are the organizations in that text, what are the people that we have on that text. You can't see. Can you see now? And what are the places that you have on that text? All these things comes as a JSON. You can get that JSON and say, so this is a summary of your document. These are the tags that you can use for your document. This is one thing you can do on your applications. Pretty easy. So if you extract the key phrases, this would be like that. Only the key phrases. Not including stop words, prepositions, nothing. That article. And you detecting here. So you can do this kind of analytics pretty easy on Azure. We'll see. All right, that has finished running. If you evaluate the model, you know confusion metrics, right? Confusion metrics, true negatives, true positives. That is for binary classification. But in here, what we use is confusion metrics. You can see overall this is getting like 95% accuracy of classifying the news. That means if you put a news article without a label, this model will give article or sport article with like 95% accuracy. What are the scenarios that you can use this? Anyone from the support sector? That means IT. You can classify the tickets that you're getting. To which department this ticket should go on. Another thing that you can use this is classifying the feedbacks. Think of like many possibilities can be done using this kind of classification, right? So that is the demo that I have done using. I've shared this thing, so you just can download this thing and use the code and all. I'm not going to show these things here. I'll show a simple example. Sentiment analysis. Have you heard of Sentiment 140, a famous web? I think normally the people used to do sentiments, and there they have a set of tweets. They have set of tweets, like 16,000 tweets or 160,000 tweets. What I have done was I classify those tweets into binary, that means good or bad. Right. After that, this was the ROC curve that I got. That was a binary classification. So you know the ROC curves and all, because we can't get the 100% accuracy. So that is using ML. That this can be directly transferred for your industrial application. That's why I chose this, not going for this one. I have the code here. If you want, I'll share. This is going from the scratch, commented here, so you can refer this thing. This is about tokenizing, how to tokenize a word. All these things are done using Python NLTK. NLTK library is having a pretty good documentation. You can read if you want. So I'll share this thing also because time is not confirming. Right. That is about the demo. And bots. We talked about bots a bit. Bots using this text analytics a lot. Have you heard about Luis? Luis, language understanding intelligence service. So not this. Before Luis, this one, Luis, language understanding intelligence service. This is a Microsoft service that you can use to understand the language. Think of this. If you're doing some kind of a bot that is going to tell you the time, right? You can ask, what time is it? And the next thing that you can ask, what's the time? Or time. And tell me the time. Or you say, what else you can ask? I want the time right now. Those are the ways that you can ask time. That means current time. The bot should understand all these sentences should go for a single output. That means giving the current time. This is done using Luis, a simple API call. Just refer that thing. And the next thing is, if you like pretty lazy, go for this site, text analytics APIs. You can do sentiment analysis, key phrase, topic detection, as well as language detection by a single API call using these APIs. Some are free, some are small price tag. Right. I chose these things because normally many people are here are not more into data side. That's it. And I did the demo. And any questions? You know this one? Any idea about this girl? This is not what we said. Any idea about this girl? Yeah, this is not actually a human. This is a robot built by a Japanese company. So this one is acting as a receptionist. Many people was not able to recognize whether this one is a human or not. That is the way that natural language processing is going on. So any questions you can ask from her or me on text analytics. Size I'll share on Meetup page. That experiment I did also, DDC specifier. Yes, lemmatization is this. Think of the word eat, right? That can come in eat, eats, eating, eaten. What else? We'll say ate, right? all these words is related to eat, right? Lemmatizing is putting those words in the same representation to the word eat. That is called lemmatization. This can use for summarizing text and all. That can be done using your pre-processing step. That can be done there. Good.
Backup works is done for entire document. Separate the document into groups.
Sorry.
Can you separate the document into groups?
Normally we don't do like that. If the document is containing like separate paragraphs, not in the same content, we'll say one paragraph is about birds, the second paragraph is about universe. So we can use we can make separate backup words for that. We can use that like that. No need of going for a page or document context.
Next slide, I think similar documents.
Yes.
Is the issue machine learning support or is the different?
For
Similar documents.
similar documents.
You have to set up document.
Yeah.
And find out what are the similar documents.
No, HTML you have to write that
In
in R or Python and use that. There's no module there. Right?
So even for TF-IDF, there is no module.
No module, you have to write that. I have done using R, but I think there are some people here. They have put some custom modules. They have built some custom modules, and they are in the market right now. So I'm going to end up the session. If you have any problem regarding this, just go for my Twitter handle and just tweet or find me in some social media. No questions, right? So thank you very much for the opportunity and hope you guys gain something or gain nothing. You see. So do the testing and do code and do test the tools and do search the things that you can't understand. Then you will learn something, and I think you'll get these things into your applications and your research or anything, and do your best in those things. Thank you.
Okay, thank you very much, Mahesh from Takelets and Harita from Tech One. I believe that everybody really enjoyed these two sessions because we really wanted to have something with practical scenario. Okay, that's why we invited these two gentlemen to do two sessions. I hope that we can actually continue with different type of topics. In the same time, if you can suggest or say these are the things we really want to discuss, and then we can find some good speakers on those whatever the subjects you really want, and we can organize our big data meetup in that way. Not only that, we really like to hear something from you. I'm sure that you have been coding, you have been implementing things related to big data. So if you can, say that we have done these things, we like to share that with the Sri Lanka community. You're most welcome. So let us know whether if you like to do something with the big data community. Another thing is we see the sort of low participation today. I think all because of the sudden weather change. Otherwise, we normally get more than 100. Yeah, sometimes like more than 150. But let's see. Let's continue. So thank you very much for coming, even with this weather condition. We'll be having our next meetup again in after 3 months, right? Okay. So keep in touch and let us know your idea, feedback through Meetup page. Okay. We really appreciate your feedback. Then only we can adjust this based on your requirements. Okay, right. We have small gifts. Okay, as token of appreciation. Let me invite Chamila Hirepan, right? To give this to guys. Okay, first Mahesh is.
I have to give away still. If someone not giving me.
Okay, you have more. Right, okay.
Yeah.
Right. I'll give it. Harita, please. Harita, can you ask a question from the market?
Two questions. You can ask one.
I think you have already given some.
Yeah, I already asked two questions.
Those are two nice notebooks. You can try once. Otherwise, I'll be keeping it.
Right. I was like this. I suggested two methods.
Just raise your hand, okay?
Yeah. Two methods to represent the documents in the mathematical way. One was the bag of word, and what is the second one? No. Raise your hand.
Matrix.
Matrix. Yeah, matrix is the way, but what is the method? Sorry. Vector, not vector analysis. Raise your hand. Yeah, vector space. Vector is vector space. Right. The next question. Okay. So this is a simple one. It will say like this. Name name 3 libraries or the frameworks for NLP. Name 3 libraries or frameworks that you can use in any language for NLP. I have used one in my code. Yes. Right. Huge. Yeah, that's it.
Okay, thanks again. Thank you very much. Yeah, I know. Tariq, thank you very much for organizing this. He's the person who really worked hard on this. And again, we thank you. Thanks, Virtusa, for sponsoring this event and giving us here the place and the food and everything. Okay, so you can go and enjoy the food. Thank you very much. Good night for you.
Finish all the food. We have a lot of food because we have prepared for 150. So only 50 is here.
Yes, you need to make sure you are done with it, right? Otherwise, we'll be having some issues.
Right.